So if you've been watching along with my videos, you've learned how to multiply fractions, divide fractions, add fractions recently. Now we'll talk about subtracting fractions and comparing fractions. Remember, to add, subtract, or compare fractions, or compare anything, to add, subtract, or compare values, they must have, what is it? The same units. So we added 5/7 plus 2/3. We added 5/6 and 2/3. We added 5/6 and 2/9. Now let's talk about subtracting and comparing them. Right? For all of these, the principle is the same. I need to get the same units. For both values, for both terms. Right? 7 times 3, 5 times 3. 3 times 7, 2 times 7. 6 is staying 6, so 5 stays 5. 3 times 2 is 6, so 2 times 2 is 4. 6 times 3 is 18, 5 times 3 is 15. 9 times 2 is 18, 2 times 2 is 4. Now, if instead of a plus sign, I put a minus sign in here, well, that's 15 minus 14. Easy. If maybe one of these is a negative, well, then it's a negative. I have negative 5 plus 4. Negative 5 plus 4, negative 1. Just by coincidence, both of these turn out to be a 1 for the numerator. Notice, 1/21 is not the same as 21/1, right? They are reciprocals of each other. 21 divided by 1 is 21. If I have 21 hot dogs to split up amongst one person, that person is eating 21 hot dogs. If I have, I'm getting a big bellyache, right? If I have one hot dog to split amongst 21 people, they're each getting one tiny little bit, just 1/21. Not the same. This one is saying that 21 is the denominator. It's shrinking by 21 times. This 21 is the numerator. 1 grown by a factor of 21, we call that number 21. Right? So don't simplify this. Do simplify this. Those are two separate numbers. All right. Now, if I just want to compare greater than or less than or equal to, now that I have the same units, I can say 15 is a bigger number than 4. Therefore, I didn't mean for that to rhyme. Therefore, this first number, 15/18, is bigger than 4/18, so 5/6 is bigger than, greater than 2/9. Right? But I can't just say, well, 5 is bigger than 2, because those units aren't the same, right? 120 is a lot more than 3. But a movie that's 120 minutes long is actually shorter than a movie that's 3 hours long, right? We need the same units to compare the values. Subtracting really is adding the opposite. So whether I write minus in front of the fraction or write plus with a negative for that second term in my numerator, it's the same thing that's going on here, right? Subtracting fractions, adding signed fractions. Once we have those same units, It's really just all about the numerator. Comparing, it's about the numerators once we have the same units. All right, so let's put this all together into one big expression. Something like 5/7 plus 2/3 minus 5/6. Why not put another minus in there? How about plus negative 2/9, right? Same four fractions we had, but put into as four separate terms in the same problem. It works the same way. If we're going to combine these terms, they must have the same units. And just like adding before, we can only add two terms at a time. The question is, which two terms do we start with? Do we start with the forward-moving terms? Right, this is positive. Plus 2/3, also positive. Minus 5/6, that's going down. Minus 2/9, that's going down. So one strategy would be get a common denominator here, get our positive fraction. Get a common denominator here, get our negative fraction. And then so you get a common denominator between those two at the end. A lot of this is really going to be guided by the particular numbers we have. Now I notice 3 and 6 and 9 all have a common factor. So I want to exploit that from the beginning. I want to think about these. Let's switch colors here. 5/7, 2/3 prime number, 5, 2 times 3, negative 2, 3 times 3. I see all those 3's running around my denominators. I'm going to say, well, this one has 2 3's. Let me give that one a second 3 here. 2 3's. This one needs another 3. Now they're almost the same, but he's got a 2, so let me give him a 2. And 3 3, he needs a 2, so let me give him a 2. Now these are all the same, but 7 doesn't have any of this. 7 needs a 2 and a 3 and a 3. I could write that as 2 times 3 times 3. But especially when my numbers are small, let me just do that arithmetic. Right? 3 times 3 is 9. 9 times 2 is 18. That's times 18. Right? 2 times 3 is 6. 6 times 3 is 18. 3 times 2 is 6. 6 times 2 is 12. 3 times 3 is 9. 9 times 2 is 18. 5 times 3 is 15. 9 times 2 is 18. 2 times 2 is 4. Okay, that's all cleaned up here. But my 5/7 doesn't have this 18. He needs an 18. Now I've got 18 times 7 here. I need times 7 over here. Now, again, this is a choice. Since all of these have 18ths, I'd much rather do my arithmetic with these three numbers than multiply all of this by 7 and then do that adding and subtracting with big numbers. So I'm actually going to hold off, leave that 5/7 there. Okay, 12 minus 15, that's negative 3. Negative 3 plus 4 is 1. Or I could say 12 is, wait a minute, I forgot my negative sign. Okay, well, let's do this in real time. I was going to say 12 plus 4 is 16. 16 minus 15 is 1. But as soon as I was doing 12 plus 4, my pen came up here and got close to this negative sign, and I remembered, wait, this last term was negative. So it's really 15 and 4 are both negative, negative 19. 12 minus 19, that's negative 7. Or we could say 12 minus 15 is negative 3, minus 4 more, negative 7. Now I'm going to get common denominators. 7 and 18 are relatively prime. 18 is not prime. It has factors other than 1 and 18, but it doesn't have any factors in common with 7 except for 1. So that's what relatively prime means. So my only choice is to multiply 18 and 7, 18 and 7. So 18 times 5, that's 90. 7 times 7, that's 49. So 90 minus 49. Well, 90 minus 50 is 40. So minus 1 less, I'm going to have 1 more, 41. Right? I could do that on the side here. 90, 49, borrow. 10 minus 9 is 1, 8 minus 4 is 4. Right? If you can't do it in your head, that's fine. 18 times 7, I can't do that in my head. That's why I was leaving it blank for now. 7 times 8 is 56. 7, 8, 9, 10, 11, 12. Now, can I reduce this? Well, think of it. What are the factors of 126? 7 and 3 and 3 and 2, right? 7 times 3 and 3 and 2. Does 3 go into 41? No. 4 plus 1 is 5. 3 doesn't go into 5. Does 2 go into 41? No. It ends in with a 1. It's an odd number. Does 7 go into 41? No, it's 1 less than 42, which is 6 times 7. So, I'm done. That's my answer. I'm tempted to do more examples where we start multiplying and adding and all of that, but you already understand how the operations work with whole numbers. If I take all these numbers here, 5/7 minus 2/3 times 4/11 divided by 2/9 plus 6/15 squared, right? This is a big messy problem, but it's not one you could have trouble with. It's not one that you need anything new to be explained to you, I mean, right? Let's look at our terms, right? To simplify expressions, first, identify the terms. Second, simplify each term independently. Third, combine like terms. So identify our terms. There's a minus, so here's one term. Minus this thing times this thing divided by, here's one big term. Why does it end here? Because now I have a plus. Plus something being squared, there's my last term. Simplify this term, done, 5/7. That was easy. Simplify this term, well, multiplication, that's 2 times 4 times 1/3 times an 11th. Now 4 I could have factored, but it's not showing up here. Dividing by 2, right? I'm multiplying by its reciprocal, dividing by 2, that 2 goes on the bottom. Dividing by a 9th, that's reverse reverse, right? So this, if I can indicate it here, dividing by 2/9 becomes times 9/2, just like minus is eventually going to be plus the reverse, plus the opposite of this term. And now I can see the 2 cancels with 2. 9 is really 3 times 3, so 3 cancels with 3. I'm left with 4 times 3, that's 12, over just the 11. And then over here, something in parentheses is being squared. So it's that thing. Let's go back to the blue. Times itself. Now, subconsciously, I must have wanted to remind you about reducing. Instead of doing 15 times 15, notice 6 is 2 times 3. 15 is 5 times 3. So this reduces to 2/5. This is going to reduce to 2/5, right? It's the same number. I could have reduced 6/15 even before I recognized the square. So 6/15 reduces to 2/5. 2/5 times itself. 2 times 2 is 4. And 5 times 5 is 25. Now to add all of this, I'm going to need the same denominator. Well, these are both prime. One doesn't have any factors in common with the other. 25 is 5 times 5. That's how we got it. I don't see 5 as a factor here or here. So I'm going to need, let's use skinnier ink here. Let's use times 25 over 25. Now they all have 25 as a factor. And 11 over 11. Already had 11. This needs 11 over 11. So I have 25, 7, 11. 25, 11, we need a 7. 25, 11, we also need a 7. So 7 times 11, 77 times 25. Didn't I say I wasn't going to do this problem? Oh well. 35, 36, 37, 38. 2 times 7, 2 times 7, 14, now plus 1, 15. So 5, 8, 9, 10, 11, 12, 5, 6, 7, 8, 9, 19, 25. Now, if you're confident that 7 times 11 is 77, I hope you're confident about that, and you're confident that 77 times 25 was done correctly here, I don't have to redo this as 25 times 77 and 25 times 77. I know this denominator is the same, right? Remember that minus sign here. This denominator is now the same for all three. In fact, let me just write that denominator while I'm writing it. Now it's just the numerator. 5 times 11 is 55. 55 times 25. Two times 5 is 10. 10 plus 1 is 11. 5, 7, 3. 1375. Let's see, 7 times 12 times 25. This is not as easy. Let's see. 12 times 25. Well, 7 times 12 I do have memorized. That's 84. So we'll just go ahead and do 84 times 25. If you don't have that memorized, you can do 7 times 12 on your own. 5 times 4 is 20. 40 plus 2 is 42. 2 times 4 is 8. 2 times 8 is 16. 8, 9, 10. 10 plus 1 is 11. So 2100. Now I could have been really sneaky and said, well, 12 is 4 times 3. 4 times 25 is 100. 3 times 7 is 21. So this is 21 times 100. There's 2100. Right? But some people get confused when I jump straight to those kind of tricks. All right, now, another thing to point out here. This whole black problem is simplified into this whole blue problem, which is simplified into this whole red problem, which is simplified into this whole green problem. When I say problem, I mean expression. Right? I'm working my way down my page with each new version of the expression. Off to the side, I'm doing that whole number arithmetic that is performing those individual operations. So when you turn in your notes, you want to show this work that you're not using a calculator. But it doesn't really have a good place to go. What needs to be organized is this expression is followed by this expression, which is followed by this expression, and so on down our page. And if I had more space, this expression would go below. Right? So just finishing out here, 7 times 4 is 28. 28 times 11, filling up my whole screen here, 28. Move over to the tens place, 8, 10, 308. So I've got moving forward, moving backward, moving forward again. So I'm going to put these two together, 1375 plus 308, both positive, 8, 9, 10, 11, 12, 13. 7 plus 1 is 8. 3 and 3 is 6. 1683 moving forward. I'll just write that. 1683 moving forward. And 2100 moving backwards. Well, 1600 is smaller than 2100. Here's my 1600 moving forward. 2100 moving backward. I'm going to end up in negative territory. Right? This answer is going to be left of 0. So my whole fraction is negative. Now, what is this numerator? We'll have to do my big subtraction here. So 21, I'll just slide down, get more space here. Okay, 2100 minus 1683. Borrow from the 0. 10 minus 3 is 7. 9 minus 8 is 1. 20 minus 16 is 4. I could borrow from here. 10 minus 6 is 4. 1 minus 1 is 0. So 417. Okay. But I'm not done, because I might still be able to reduce this. Now, what are the factors of 1925? 7, 11, 5, and 5. 7 times 6 is 42, so 420 is a multiple of 7. This is only 3 away, so 7 is not going to work. 25, that's 5 times 5. 5 doesn't go evenly, doesn't end in a 5 or 0. 11, well, 7 plus 4 is 13. That's not going to work out. That's kind of a cheater shortcut, so we'll just do a quick long division. 11 times 3 is 33. So 87. No, it doesn't work out. We're close. If this had been an 88, 418, that could possibly work. But it doesn't work out here. So none of these factors of my denominator go evenly into my numerator, so I'm done. So order of operations. Certainly this problem takes longer than if I didn't have to worry about those denominators. But the process is the same. I'm doing the multiplication by recognizing 2 halves is 1, 9 thirds is 3, 3 thirds is 1, so 3 times 3 is, 1 times 3 rather, is 3. Right? So there's my 3 times 4 to get the 12 here. I'm dealing with this multiplication completely separate from this multiplication. This term is independent of this term. I don't care that this denominator is 7 and this denominator is 11 until I get down here, and now I'm adding or subtracting, and then I need to have the same units. So there's order of operations with fractions. You're welcome.